Hello and welcome to the class on what are days, seasons and years. So I'm Laura Lewis, and see the animation I've got behind that of seasons to go with this PowerPoint. Okay, so let's look at the learning objectives. So describe how the motion of the Earth causes days and years. Number 2, understand how the tilt of the Earth on its axis causes seasons. And 3, how to answer questions on days, years and seasons. So we'll answer questions based on all of those. So let's have a look at an overview first of all. Okay, so we've got the sun, the earth and the moon there. So the earth orbits, so it goes round in a circle, the sun. So the earth orbits the sun. That's need to be quite clear about, as the earth orbits the sun. The moon then orbits the earth. The moon orbits the earth and they orbit together around the sun, but we say that the earth orbits the sun. So the earth orbits the sun in 1 year, which we'll talk about more in later slides, but the moon orbits the earth. So the moon takes approximately 1 month to orbit the earth. You may notice the moon changes shape throughout the month. These are known as the moon's phases. And there will be another video about the moon and the tides and the phases and how it affects things on Earth. We'll just talk about the Earth and the sun today mainly. So Earth is also a planet in the solar system. So the solar system is the sun and all the planets. There's also asteroids and comets that talks about and other things. Okay, but we'll just talk about the planets today. And the Earth is the 3rd planet from the sun. Okay, so the other planets, you can see that they're sort of drawn on here. Okay, they're not really this close in real life, but they're obviously just drawn to illustrate they all orbit the sun. So they orbit the sun in their own orbits. Some take less time than the Earth, so the planets nearer the sun take less time than the Earth, and others take more time. The planets that are nearer the sun yet take less time, and the planets that are further away. Okay. Let's look at day and night to begin with. So the Earth revolves on its own axis. So the axis is an imaginary line. So the Earth's tilted. That's why this is a good photograph. Okay, the Earth is actually slightly tilted relative to its orbit. Okay, so the Earth revolves on its own axis once every 24 hours. So when seen from above, the Earth turns anti-clockwise. So think about a clock face, that's clockwise, the way that the hands go. If you look from above, look from up here, the Earth turns anti-clockwise. So the side of the Earth, so imagine the sun's over here, the side of the Earth facing the sun experiences day, whilst the side facing away experiences nighttime. Okay, so day 24 hours, because some people get mixed up and think the day is just when it's light. But if you think about the day, say example, it's Friday today. Friday began midnight, and it lasts 24 hours until sort of like the next midnight, doesn't it? So it actually just lasts 24 hours. Okay. So other planets also rotate on their axes. And it doesn't depend on how big the planet is. So we've got Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So Earth, 24 hours next day. Mars is smaller than the Earth, so these are not to scale in terms of their size, but they scale in terms of their day. If I could put a creative graph, Mars takes longer to actually spin on its own axis. Okay. Jupiter, the largest planet in our solar system, only takes 10 hours. It spins very quickly, so it rotates on its own axis very quickly. So the day on the planet is its rotation. Okay, so like the day and the night on that planet, if you imagine being on that planet, that's day and night. This is a rotation. Okay, so so it doesn't matter, it doesn't depend on the size of the planet or its distance from the sun, the day. Okay, so don't get those mixed up. Okay, so the day is independent of its size and its distance from the sun. It just depends on how long it takes for it to rotate on its own axis. Okay, go and have a checkpoint there about day and night. So I would encourage you to pause the video because this is recorded and to write down the questions and go back and check your answers. Okay, so we'll get a comprehension to make sure you're sort of taking in the information here. Okay, so here are the answers. How long is a day on Earth? So a day on Earth is 24 hours. What does the Earth orbit? The Earth orbits the Sun. What do we call the imaginary line that the Earth spins about? The Earth's axis. So if we talk about another planet, so Jupiter, it would be Jupiter's axis. Okay. Which planet has the shortest day in the solar system? So Jupiter has the shortest day in the solar system. 5. What does the moon orbit? The moon orbits the Earth. 6. Approximately, how long does the moon take to orbit the Earth? The moon takes 1 month approximately to orbit the Earth. Okay, years. Okay, so now we're on a bigger scale of the Earth orbiting the Sun. Okay, so this is like looking down. Got like a little, just like a stick, that's the represent the axis. Remember, it's not actually there, it's imaginary. Okay, so the Earth takes 365 days to orbit the Sun. It actually takes 365.25 or 365.25 days to orbit the Sun, and we add on an extra year, so extra day, sorry, every 4 years, and that's a leap year. Okay, the time a planet takes to orbit the Sun is known as its year. So Mars is further, so you've got Mars on the same diagram here. Mars is further away from the Sun than the Earth, so it has a larger orbit. You can see it's got a big orbit here. Okay, so think about it, it's got a bigger circle, it's further from the Sun. So the larger orbit means it takes Mars longer to complete one orbit of the Sun. So 1 Earth year is 365 days, 1 Mars year, 687 Earth days, or 669 Sol Martian days. So remember on Mars, the day was longer, wasn't it? Okay. Not that much longer than the Earth, but a little bit longer. Years on other planets, again, so this is how long the planet takes to go around the Sun. Okay. So Mercury and Venus are closer to the Sun than Earth. Okay, and their orbits are smaller. So this year does depend on how far they are from the Sun, and that questions will be asked on that in tests and things. They'll be asked about how the distance from the Sun affects how long the year is, how long it takes to go around the Sun. So lots of questions like that. So the year does depend on it. So Mercury, very speedy planet, only takes 88 days, so around the Sun in 88 days. Venus 225 days, so shorter. There's Earth 365, and then we got it goes up quite dramatically. Mars 687 days, Jupiter 12 years. So you can see how far these planets are from the Sun. 12 years, 12 times longer. Saturn is actually quite a distant planet because Jupiter and Saturn are not close to each other. Saturn's a lot further out. If you see it in the night sky, even though Saturn is a huge planet, it looks quite small in the sky. It's so far away. 30 years. Uranus, 84 years again, very long time. Neptune, 165 years to go around the Sun. Actually, Neptune was discovered less than 165 years ago. You need a good telescope to find it. Actually, it has not completed one orbit since it was discovered. Pluto, no longer a planet, but still in its diet, 248 years. It's a long way from the Sun. Okay. So we're going to take a checkpoint here. So there are blanks. Where there is a blank, it means that there is a word to fit in. Okay, so there's a word to fill in the blank. So it's a good thing again to pause the video and try this yourself. But yeah, all the answers, either what I've said them or they're in the PowerPoint. So make you think a little bit as well. Okay, I'll go through the answers here. I've just filled it in. Earth takes 1 year to orbit the Sun. 1 year is 365 days. It is actually more accurately 365.25 days. Every 4 years, we add on an extra day. These are known as leap years. The further from the sun, the longer a planet takes to orbit the sun. So the longer its year. Saturn is very far from the sun, so it takes 30 years to complete one orbit. Mercury is the closest planet to the sun, so it has a small orbit. The year of Mercury is only 88 days. Okay. Seasons, finally. Okay. So we're going back, talking about the Earth's tilt. Okay, we saw a little bit which tilted, but now it comes a bit more important. So the Earth's axis is tilted at about 23 degrees relative to the orbital plane. Okay, so you can see here a bit more clearly. Okay, so this causes the Earth to have seasons. So if it didn't have that tilt, it wouldn't have seasons. Some planets in the solar system don't have a tilt and don't have seasons, but the Earth does. So when the Earth is tilted towards the sun, okay, in the northern hemisphere, so here you can see it's always pointing. If you sort of follow it, it's always pointing at the same place, the axis. We'll talk about that a bit more in a minute. So when it's the Earth, so seasons are not caused by the distance between the sun and the Earth, they're caused by the tilt completely. Okay, so when the Earth is tilted towards the sun here, we experience summer in the northern hemisphere. Okay, so southern and the southern hemisphere experiences winter. Okay, and we'll go over to the opposite side for a moment. When the northern hemisphere is tilted away from the sun, we experience winter in the northern hemisphere and we experience summer in the southern hemisphere. The in-between times are the spring and the autumn. If you look at here, you can see that in the winter, in the northern hemisphere, there's going to be some part, the North Pole, for somebody that's called the Arctic Circle, is always going to be in darkness. And the same with Antarctica, you can't really see it that well, but Antarctica here, in its winter, there'll be parts of the Earth down here which will have 24 hours of darkness as well. Okay, and you can also tell from this diagram, in summer, okay, so we actually have longer daylight than the winter because we have longer time in the sun. This bit's bigger than this bit. Okay, so we have so the equator, it wouldn't make a difference, but because I'm in the UK, I'm sort of up here, that we would experience longer daylight in the summer. Okay, all the UK would experience longer daylight. Okay, so let's talk about what the Earth's axis is pointing at. Okay, so the Earth's axis is the imaginary line. Remember, it doesn't actually physically exist. It's an imaginary line we draw, and it actually points towards a star. Well, the star happens to be there. So the star isn't actually special. Happens to be right near where we draw the axis, called Polaris. Okay, Polaris. So also called the North Star. So it's not the brightest star in the sky, Polaris, but it's important because it's used for navigation, so finding people's way north. Okay, so this is how to find it in the sky. In America, it's called the Big Dipper. In the UK, we call it the plough. I think it looks like a saucepan, really, whatever you want to call it. Its proper name is Ursa Major, okay, part of a constellation. And if you draw a line here, you get to Little Dipper, or that small plough, okay, Ursa Minor, and its tail star is Polaris, okay, and that lines up pretty much with the axis, so it points north. That's why it's important here. If you actually take a video of the stars in the sky, okay, that's Polaris in the middle, and all the stars appear to go around it. But of course, the stars aren't moving, it's the Earth that's moving, so it's moving around the axis. So where Polaris is for you in the sky depends on where you are on Earth. So this is actually nearer the equator in the UK. In the UK, it'll be somewhere up here, depending on how far north you are. If you were right at the North Pole, it'll be right above your head. Okay, it'll be right up 90 degrees over your head. Okay, so it depends on Earth, but it's used for navigation. That's why it's important star. So checkpoint, seasons. Okay, so it's the last checkpoint of this presentation. Now we'll go through the answers. How many degrees is the Earth's axis tilted by? the Earth's axis is tilted by 23 degrees. 2. When it is winter in the northern hemisphere, what season is it in the southern hemisphere? Summer. Okay, it's summer, so it's the opposite season. What months of the year are the northern hemisphere winter approximately? Okay, so in the northern hemisphere, we generally count December, January, and February as the winter, okay, months. Is it true that the seasons are caused by the Earth being closer to the sun in the summer? No, this is not true. It is caused by the tilt of the Earth's orbit. Okay, so that's an important one to remember there. The seasons are caused by the tilt of the axis. Thank you for listening to this video. Hope to see you in a future one. Thank you. Goodbye.